Okay, in this lab, you are going to talk about, you're going to do some stuff with the difference quotient. In calculus, you will learn this, and then we'll show you a trick, which is differentiation, all right? And the purpose of this might look funky to you, this formula. It's really slope, because remember, you shove in an input, you get an output, right? This is a y value. So do you see how this is like y2 minus y1? And this is x2 minus x1. And notice h is our shift. So we have a function and we're shifting it. And usually we find the secant line, right? So we find the slope of the secant line. Then we sub into y equals mx plus b. And then we find the equation. We find the y-intercept. We find the equation of a secant line. All right. What about the tangent line? So remember a tangent line. So if I have, say, a parabola or whatever, secant line goes through 2 points, right? So a tangent line would just go through 1, right? And so a lot of times we want, this would have a rate of change, right? This top line. Sometimes we want the instantaneous velocity at a certain point. Okay. So like on a roller coaster, yeah, we could pick 2 points in time and be like, oh, on that little stretch, you were going 65 miles per hour. But what if I wanted to say, well, yeah, but what about exactly at that point? What was my speed at that one moment in time? All right. And so that's kind of what this does. All right. I'm going to take the problem that was on the quiz and let's do this. Now, remember, the word input is probably a better use than x, because x can be ugly. All right. So whatever, remember, x is whatever input you're given. Okay. This is saying input x plus h. This is your input into that function. Okay, so we're going to put that in there. So this is what you're supposed to do on the quiz. Okay, FOIL this out. You can either do the box or you can FOIL, but remember you should get a trinomial. So multiply that out, and then I'm going to distribute that. And notice you're going to get a lot of h's, and I'm going to distribute again. That's an h. So on the quiz, that was the first step. Okay. Then the second thing I had you do on the quiz, I didn't give you the formula, but I said now subtract f of x. Now, this is the original function, right? There's no shift on it. So this is the function with new input, a shift. This has no shift. So here's your answer to the first part. Now we're going to subtract. Now again, always a good idea. You might even want to put that around there, because when you subtract in algebra, you have to do the distributive property. So distribute, distribute. Okay. So I am going to add the opposite. I think I have a highlighter here. So I like to add, make that negative, negative. Okay. All right. So let's get the answer for that part. Now notice all the x things should cancel, you know, fairly. Did I lose? This should be 2xh. Gosh darn it, Julie. All right, so when I did this, I should have had an XH here, XH here, so 2. So I lost my H there, so sorry about that. All right, the reason I caught my error is because this should cancel all your X's. So when I saw like something without an H, I'm like, oh, shoot, I screwed up, right? So I caught it because I know how these things work, which in math is huge to know when you made a mistake. There we go. Okay, so what's left? I'm going to write this kind of in an order here. 3h squared plus 10xh plus 3h. Okay, and then the last thing I said on that quiz to do was divide by h. All right, and notice how lots of these things are going to cancel here. So I get 5h plus 10x plus 3. Okay, and I might even, I'm going to put the h at the end. So I'm going to 10x plus 5h. Oh, Julie, oh my Lord, 10x plus the 3, and I want to put the 5h at the end. Okay, that's my difference quotient. All right, now, what does this do? Okay, so in calculus, you're gonna do a little step more with this. You're gonna say, okay, the limit as h goes to 0. All right, so I have 10x plus 3 plus 5h. So h can't equal 0 because dividing by 0 is a bad thing in math. But as it gets infinite close, right, in a sense, that's going to go away, okay? And you're going to get 10x plus 3. that is the derivative of that function. Okay, it's a derivative, and it usually, deals with velocity and things like that. Okay, now in calculus, they're going to show you a shortcut later that you're going to be mad about, but you take 2 times 5, you get 10x, you subtract 1 from the exponent. So you take the 2 times 5, subtract 1 from the exponent, and then plus, and there's an invisible 1 here, 3 times 1, subtract 1 from the exponent, you get x to the 0, and that's what you get. Okay, so then what you can do on your graph is you can sub in a point. So say like your input is 1, okay, then at 1 you would get what, an output of 13, and that would be like your, probably your velocity or some value that you care about at that point. Okay, all right, so all right, let's do another one, and then I'll show you the graph on this one. All right, so let's look at this guy. All right, let me just grab a new page and we'll do this one. This one's not as ugly. All right, so first step is sub in x plus h. And again, even when you see an x here, remember, it just means input. It doesn't, like this x and that x are not the same x. This x stands for input. All right, so I have 3, x plus h, that's my input. And again, if you do the box or do FOIL, and I won't screw it up this, I'll get 2 xh's. Okay, so again, if you want to do x plus h, and fill out the box, then I'm going to distribute. Oh, Julie do. Plus 3h squared. Okay, 3x, 6, and that. Okay, and then minus 2. All right, that's just the first part of that formula. That's just this. Now it says subtract status quo, the function that you had. All right, so here's a function I just got. Minus, and again, you have to use a distributive property. I'm just going to sub in my original function. I'm going to distribute, which again, I like to add the opposite. So I'm going to change this to adding and negative, positive, do the opposite. And again, if you're doing this right, the things that are x's or things that don't have h's should cancel. Okay, so I know this guy cancels and that what? Minus 2 and positive 2. Okay, so I get 6xh plus 3h squared. Boy, if I can talk. The last step says divide by h. All right. So again, we're just finding the rate. We're finding the slope, the rate of change. Okay. So here I get what? 6x plus 3h. Okay. And that's where we're going to end in pre-calc. In calc, you would say, okay, the limit as h gets really small, gets super close to 0, but again, can't equal because dividing by 0 is a big no-no in math. But in a sense, that would give you 6x. Okay, so this is the answer for us, but you're going to keep going. Okay, now again, notice the trick that you're going to learn later to do easy differentiation is you're going to take 2 times 3, which is 6, subtract 1 from your exponent. Now constants don't have, it's technically x to the 0 power, so 0 times that is 0. That doesn't do anything. So this is what we would call your derivative, but that's what the difference quotient gives you. Okay, now what I want to do is kind of put this on a graph so you can see what I'm talking about. All right, so I graph this on Desmos. So let me get to Desmos. Let me get out of this. Oh, come on, helps if I get out of it. All right, let's get out of that. And I have Desmos pulled up here somewhere. This is a quiz that we went over. Okay, where's my Desmos? Okay, so I graph my original function. And I subbed in some input and output, and I got some points. Okay, so remember, I could find the slope between these 2 points. Let me undo which one's in the middle. Let's get rid of this one. All right, why won't it hide it? There we go. Okay, well, unlabeled. Okay, say I want to find the slope between these lines. 10 or points. 10 minus 1 is 9. 2 minus 1 is 1. I would have a slope of 9. The rate of change between those is 9. Okay. If I want to get rid of, let's see, the 2 one and put here, okay, my rate of change would be what? 3.75 divided by 0.5, so what is that? Is that 7.5 or something like that? Okay. But what happens, and again, I'm just going to hide, I want to keep that guy. That's the one I'm paying attention to. All right. So what happens, I'm just going to slide up and down here, okay? So what if I get really close to this guy? All right, so we're gonna get super close, as close. I'm gonna try to get as close as I can. Let's try without, that's not bad. All right, what do I, oh boy, we'll use that. 1.04 and 1.245. Okay, I'll try to remember those. Okay, see my brain, I can't do that. I wish I could take a screenshot, but I need my hands. All right, can I get a little closer? Okay, 1.024. All right, I'm gonna write that down and I'll probably have to, 1.024, got that. And then, sorry, this is the problem with being old. Oh, that's even better. That's easier. It's not closer though. Can I get back to my 1.0? No. Okay, we're gonna use that one because I can remember it. 1.01 and 1.06. 1.01, 1.06. Okay. And again, I could do input and output to get that. But what I'm trying to do is basically find that instantaneous slope, right? But obviously you need 2 points to find slope. So I tried to grab ones that were really, really close. And where did my ladybug go? All right, I think it's gonna have to reload. Sorry about that. All right, come on, you can do it. Okay, there we go. And notice there was one time I had you sub in input and output. I think it was the bisector method maybe. But notice if you want to get this point, I could sub in. So let me grab my TI or I'll just grab my phone here. If my input is 1.01, so I have 3 times 1.01, and that was what, squared? Okay, and then that's my input minus 2. All right, so it gives me that output. Now this is rounded. Is that okay? On decimals, I just got a rounded number, but we'll just use this. It's fine. Okay, close enough. All right, so what I'm going to do is basically, here's my parabola. I have these 2 points that are almost on top of each other, but you get that's still a secant line, technically. All right, I'm going to find the slope. Okay, so my original point, I'm going to make an input-output chart because I think they're helpful. 1, 1, and then we were comparing it to that. Okay, I like to find slope by change in y over change in x. I just think it's easier. So my change in y is what? It went up by 0.06, and my change in x went up by 0.01. Okay, so notice my slope is 6. Okay, if I wanted to find the secant line, what's step number 2? You write the function, a linear function, right? Just like we always do. If you want quadratic function, you'd write a quadratic function. You fill in what you know. Okay, I know my slope is 6. I know input output. I'm going to pick the easy one, is 1 and 1 plus b. So 1 equals 6 plus b minus 6 minus 6b is a negative 5. So I could write my equation. My function y equals mx plus b or minus b, whatever the case may be. All right, that's my line. That's my secant line, okay? And I could graph that and it would go through those 2 points, but kind of tiny. All right, but what I want to look at is I want to go back and be like, okay, so yeah, what about over here? Okay, and you're like, Julie, you're saying this is somehow connected to slope. Well, if x equals 1 for input, what do you get for output here? 6. What did I get for the slope? Even that tiny distance in between. What was the rate of change when they were really close together? 6. So do you get that is kind of that instantaneous rate of change at that point? So at 1, if I was going to get the velocity of my roller coaster at that point, right, that would be 6. So I can take that difference quotient, right? And again, it's after you do the limit and all that stuff, right? Because the h part has to go away. But I can sub in my input of the point I'm at. And if I sub in 1, I get 6. That is my instantaneous rate at that point. All right, I'm going to have you guys try it. It's called the difference quotient. Excuse me, you will do it in calculus. All right, give it a try.